Myself Mangesh Fadke and I will be teaching physics for 9th standard. So let's start with our first chapter, laws of motion. Before starting the chapter, we need to know what is a law. A law is a scientific statement proven by experiment. Even if 100 scientists perform the experiment, they will get the same result, and that result is termed as a law. A law cannot be challenged. So let's start with our lesson, law of motion. Before starting with the main laws, we need to get acquainted with some basic concepts. So first, we need to know what is distance and what is displacement. So here I have made a right angle triangle, triangle ABC. Here angle B is my right angle. So if I take a vehicle and travel from A to B and then C, the total distance which I covered, that is length ABC, will be termed as distance. But if I take a smaller minimum path, that is from A to C, that path length AC will be termed as displacement. So if we talk in the terms, distance is the total length traveled from the starting point to the ending point, while displacement can be defined as the minimum distance between the starting point and the ending point. Your brain. Here we have our first question. Swarali walks round the edge of a circular field having a radius of 100 meters, as shown in the figure 1.2a. If she starts from the point and takes one round, how much distance she has walked and what is her displacement? So first we need to understand the question. So here Swarali takes a circular path. So she moves in a circle. So here we need to understand one thing. For example, if we take this as point A, this is the starting point. So a circle has the same starting and the ending point. So Swarali will start from A, cover a distance and again come on point A. So here we will calculate the distance. But as the starting point and the ending point is same, so is there any change in the original position? No. So our displacement will be 0. So whenever we calculate any kind of length of distance and displacement, we use the unit meter. So now we got the displacement. Now we need to find the distance. So some data is being given to us. So it is told that it is a circular path. This is the center point and the radius given is 100 meters. This is the given data. So using this we need to find the distance. So basically, if she walks in a circular path, it means she will be on this edge, that is circumference. So to solve this, we will use the formula of circumference of circle. That is equal to 2 pi r. We all know this formula. So we have been given data. We know the value of pi. The thing we will do is substitute in it. So now we will substitute the given value in this formula. 2 into. As we know the value of pi is 22 divided by 7. And radius is given 100 meters. Now just you have to solve it. 22 into 22, 44. Into 100, 4400 upon 7. When we divide them, we get the answer 6628.57. If we approximate this answer, we approximately get the answer 628.6 meters. So here, using the formula, we found that the total distance covered by Swarali is 628.6 meters. But it is a circular path, therefore the displacement is 0 meters. Our next concept is speed and velocity. We saw the difference between distance and displacement. Same follows for the speed and velocity. So, speed is defined as total distance covered upon given time. So if we cover some distance in the given time period, that is termed as speed. And velocity is slightly different. In speed, we cover certain distance. Velocity is in terms of displacement in given time period. So speed is for long distance. Like while we travel on a bike, a car, we calculate in speed. We calculate the longer distance. While in terms of lab experiments, in terms of when we are researching on something, we use the velocity because in that we don't take large distances. We take very small displacement which are very minute. So if we see the unit, we measure distance as well as displacement in meters. And time is measured in seconds. So the unit becomes meter per second, which is symbolically written as m upon s. This is in the standard unit, which we call as system internationally, SI unit. We can convert them accordingly. If the distance is very small, we can take it into centimeters per second. Or we are traveling in a vehicle, we take the larger difference, kilometer 1 second. However, every time we take speed or velocity, it has to be divided in measures of time. The meters, centimeter, kilometers, length can change.